All right, so today is actually the third training day that we've been looking at. We've been looking at core Python, Python basics. We dealt with strings. We've touched tuples, dictionaries, list, and today we want to start. We've touched a little bit of control statement in terms of the if statement, if X or if S, but we want to dig deep a little bit into it today, and then we'll also look at the loops, like the for loops and the while loop, just a little bit of some of these things. We're not going to go into detail because that's not, we're just trying to familiarize you with some of these things so that by the time we start working with data, we'll be making use of them. You already know how to write at least some loops, to put together some of these things. So the question is, what are control statements? These are just normal words. Control statements are series of rules, series of statements that a program needs to follow to get the desired results. Those who did computer science use the word flow chart, something like that. The control statement is not a flow chart, but it's just the idea of flow chart is also the kind of rules that your program will follow to perform a particular task. So that's the kind of idea of a control statement. And under the control statement, we have some conditioning statements like the if-else statement. For instance, when you go to your ATM, you want to withdraw some money from your ATM machine. When you slot in your card, you realize that when you put in your card, it will tell you to enter your PIN. If you enter a wrong PIN, it tells you invalid PIN or something like that, and tell you to put in the correct PIN. That's if-else statement, control statement, that if so person, if your PIN is wrong, what you do, print, enter the correct PIN. So these are programming in place. So some of this, most of everything we use, most of the things we use in our day-to-day, they are done. They were actually obtained using programming language like the if-else, the control statement. So, for instance, let's look at the question. It said, write a program to ask for a user's password. And it should be N, display access denied for incorrect password. So the first thing, like I told you in our previous classes, that when you want to get something from a user, you use the keyword input. You use the keyword input. And then what do you want? So input is just to get something from a user. Since we are not converting it, since we want to get a string, a user's password is a string, so we don't need to wrap this around int. If it's a number, we'll wrap everything around that. But since we are not, we just use input and then pass in the instruction, enter your first name. We also want to get a password. Okay, enter your password. Make sure you put input. Now the question is, we want to ask for a user's password and display access denied for incorrect password. So since we are talking of incorrect password, that means we need a way to let the program know there is a correct password. So in this case, let's say I'm using the correct password to be, maybe this is a security stuff. So let's use MI6. So that's the password. That if the password the user enters is MI6, remember, anytime you use if, you must end it with a colon. And then this 2 equal sign is an equality sign. So if the password the user entered is equals to MI6, just print welcome and then put the name of the person. So if you do that, if we run this, if we bring out the name, let's say I'm using my name, Kenny, then it tells me it's following the instruction you are giving to the computer one by one. Okay? Enter a password. Suppose I put MI6, just like that. It will tell me welcome. But if the user puts, let's see if when the user inputs a wrong password, let's say like the user put love. It didn't work, it didn't give you the print welcome, but because your program, sorry, I just need someone to confirm. Can you hear me, please?
Yes.
Yes, sir, we can.
Okay, okay.
Yes, sir.
Because I'm seeing unstable, so all right. So it actually worked, but because you supplied the wrong password, it tells me that it just moved on because the program does not have the next instruction. It didn't tell us welcome, so that means that a wrong password was entered, but it didn't tell us any other thing because that's the end of your program. So that's where S comes in. That, if this statement doesn't work, then go to this next statement. That's why it's very rare for you to see a Python, an if statement that will just be only if statement. Most often it will be if S or if S and if elif S. So meaning you have to supply the other condition. So the same program asks the user to supply the first name, asks the user to supply the password. If password equals to MI6, then print welcome, let's welcome the person. S, meaning if the user does not enter the password correct, print access denied. So when you do that's exactly what you see in that ATM stuff. That, if your PIN is not correct, print invalid PIN. And we can even do that here. So enter your name, your first name, Kenny, a password. Instead of MI6, I put love. It tells me access denied because it will only come to the else statement if this if block is not satisfied, if that condition is not met. But if the condition is met, then we will not, it won't print, it won't go to the else statement. But it will check that once the if block is not met, it jumps to the else block. That is how that works. So let me quickly move to if elif S. In C++ or even in R programming language, when you do if and you want to introduce an else if statement, you print it out as else if, like else if. You spell S, put space, and then if. But it's the same thing in C++. But in Python, Python shortened the else if to elif. EL stands for else, and then the if. But every other thing was the same, like the same way, but just the spelling is different. In Python, you don't spell the S if in full, you use elif. So for instance,
Mr. Kenny.
Can you hear me, please?
Oh, you're back.
Maybe Mr. Timothy is right with this Nigerian.
Welcome to Nigeria.
Oh my God. I'm going to reshare it. It is well. Okay. So sorry. Can you hear me clearly now?
Yes.
All right. Okay. This is great. Okay, so I want to move to the if elif else statement. And let's look at the question here. I have a question that we want to write a program to display the score of students. That if any student that gets a grade above 4, you should give us A, above 4 points, and grade below. Just based on this table, we want to follow the condition of this table and write a program that will display their grade based on their scores. So what we can do here is that, first, we need a way to get the score of a student. Now, because we can have decimal points along the way, that's why I'm using float. Remember, anytime we want to get something from a user, use the word input. So input, enter a score, okay? And then we convert whatever score the user is giving us to a float, because if we did not convert to a float, if we put it as an integer, If you enter 3.5, it's just going to give you the integer part, which is 3. It's not going to round it up. So better, just convert it to a float. Okay, that will allow the decimal point. Now, because we have condition like, oh, we want all grade above 4 to be A, that's where if comes in. That if the score is greater or equal to 4, we want 4 and above. What do? Print grade is A. Now, we have more other conditions, and that's why we're going to use the word elif. If it's just one condition, then you use just the if statement. Now, but because you have more than one condition, you use also the elif statement. Like else, if score is greater than 3 and score is less than 3.5, print grade is B. Like that. Else, if score is greater than 2.5 and score is less than 3, print grade is C. Now, because the last condition is D, I don't need to use else if again. Everything below 2.5 can fall under D. That's where the S comes in. So S, when you're using the if, elif, S statement, the S will become the last condition. S, print the grade is D. So if we run this, it tells us, okay, enter the score. So suppose I put 3.49, that's what? It tells me the grade is B because it's still below 5. And if you run it, let's put 2.49, that is below 2.5. It tells me the grade is D. Any question on the if, else, else statement before we move to loop? Any question?
No.
Okay, good. I know we have been used to this, so I won't want to spend much time on that. I said we have questions. Okay, so now loops. We've been using loop a little bit like that, but I just want us to discuss it in detail. Not so much detail, but at least an understanding of it better than what we've been doing. There are loops is just like an iteration. Like if you want to iterate, you want to go through all the elements of a particular list or a string, then you use the word loop. Loop means like going through each of them. Now we have two types of loop. We have the definite loop, the one where we know the number of times we want that iteration to go, and the indefinite one where we don't know, but there is still a way we can make the indefinite to be definite. So, and that's where the for loop and the while loop. The for loop is under the definite loop, and the while loop is under the indefinite loop. But before we look at that, we've been using, I think last class, or we used the word, the program, the function range. Range, just not as it means in mathematics. I know in mathematics, range means the difference between two numbers. It's kind of similar, but when you say range of 10, it means you want to go from 0 to 9. But if you want to see the number, just wrap this range around the keyword list so that it will list out the range. So if you see range of 10, it gives you 0 to 9. If you do range of 2 to 10, it's going to give you numbers between 2 and 10, which is like 2 to 9 like that. So if you list that, it gives you 2, 3 to 9. Similarly, now when you include the third argument is just like a step. The step at which you want the number to go. You want the number to go from 2, it's not going to include 10, it's going to stop at 9, but you want it to go in step of 3. So if you do that, it goes 2, 5, and 8 in step. So things like that. So that's how the word range. So let's move to for loop in detail. Definite loop, like I told you, that under a definite loop, is actually a loop that you know the number of times you want to execute the process. So for instance, you want to write a program to display hello world 3 times. So we know that we want this to run 3 times. So that's a definite loop. That's where for loop comes in. And that's why I say, oh, for I in range 3, range 3 is 0, 1, 2. So you don't really need the 0, you don't need the 1, you don't need the 2. You just need the number of times. So for I in that range, those three numbers, print hello world. So the first time this will go, is going to go for the first round, print hello world. Second, print hello world. Third, print hello world, like that. So, you know, in summary, what I'm saying is your for loop is a definite loop. For instance, look at this second question. It said, write a program to display each character of the string machine learning. So we can do for I in string 1. Always end the if statement, the for loop, always ending with a colon. For I in that, in string 1 is already machine learning. What I want to print its character, so which is I. Anytime you do for I is just like a counter, is an iterator. It's going to go through each element of that string. So the first time I will represent M. The second time it goes to pick A, like that, C, H, and so on like that. So if you run this, you will see the result. It prints out each character, machine learning, because I is now representing each letter, each alphabet there in that string. Now, but for indefinite loop, you are using the while statement. Everything while loop can do, a for loop can do. A for loop is actually easier than while loop, but sometimes you might need while loop, especially when you are dealing with indefinite stuff. Like you don't know the number of times this is going to work. But however, if you're using while loop, you have to include a statement that will help us terminate it so that your program will not run forever until your laptop dies. So look at this example here. We have a savings account. Let's say the savings account is 5678143. Now we want to get input from a user, meaning we want the user to enter an account number. So if that account number is not equal to the one we already have in our system, we want it to print wrong number. And then we want to print back the account number that the person put. So that's why I put here. So let me even comment out the second line. So that's why I put, the savings account that we have here is the one we already have in our system. So, okay, so the reason I put this second line here is because the while statement, you must supply the while statement a condition to work with. What that condition, what it will do is that the program will keep running as long as the condition you put in front of this while statement, this while number, this number not equals to. See the exclamation mark because before equals to, it means not equals to. So the program will run as long as this condition is correct. The moment this condition is false, the program will terminate. So that's one way to terminate an indefinite loop. So while the number that the user is giving us is not equals to this saving account, it will keep on printing wrong number. And then we want him to enter the right number again. Oh, enter the right account number, things like that. So if we run this program like this, it tells us that, okay, enter your account number. That's the one before the savings account. Enter your account number. Let's say I just put 56718, which is not correct. It tells me wrong number. Enter the right account number, because we want to keep on telling him to give us, the right number. That's the right number is you are seeing here is the one inside the for loop. If you don't want to correct it, this will only print once. It only give us once. It's only going to do that once. But because we want him to keep on, so because we want him to keep on getting this number, asking for this number, we have to, that's why I put that line there. So suppose I put the wrong one again, 5671814. It tells me again wrong number. But if I put the right one, 5678143, then it's correct. That's when now you can see now that is when the while loop terminates, and then it prints this last line there, that, oh, account number is this. So as long as the user keep on giving us a wrong account number, it's not going to work. It's just going to keep on working. That's why we call it indefinite. It's just going to keep asking the user to enter the right account number. Although there is a way we can make it such that we only want it to ask 3 times, you know, and maybe after the 3rd time, you can say, oh, you can lock the person out, things like that, you know, so that it will flag it like, oh, maybe someone is trying to steal your account number, things like that. But that's still under the while loop. So any question before we move on under the while loop? Any question from anyone? Are we good?
Sorry, Mr. Kenny. Sorry to drag a little back. Can you help me scroll through your notepad up? Hello?
So which one exactly?
Hello?
I'm with you, sir. Which
Hello,
one
Mr.
exactly?
Kenny, can you hear me?
I can hear you clearly.
Yeah, I'm trying to run the same thing that you taught.
So which one? Is it the for loop or the if statement?
Just scroll up. I can barely hear you. No, not the for loop. The else statement, the if else statement at the beginning. I think.
Okay.
Scroll up a little, please.
Yeah, this is the beginning.
Yeah, a little.
So can you hear me clearly?
Okay. Okay. This if statement that if the person put the wrong, that if somebody put the wrong password, that's going to put access deny. So I'm trying to put the else statement here, but it's giving me a kind of error.
So watch your indentation. Your else has to be in the same line with the if statement because it's also a condition. So that might be an issue. You can see mine. That when you want to put the S is the same line, the same indentation with the if statement. So that might be the issue. So I will even suggest that.
Okay.
When we go to the breakout room.
Okay, got it.
Yeah. So I would suggest that let's try and listen more in the class, and then when we go to the breakout rooms, you can practice that so that so we can cover a lot in short time. Are we good?
Okay. Sorry for bringing me back. That's fine.
That's fine. All right. So now to continue with the while loop, look at the question. It said, write a program to sum numbers 1 to 10. Now, because it asks us to sum numbers 1 to 10, we need a sum. And we also we want to use. Okay, so.
I can hear you.
Yeah. So to continue with the while loop.
I can hear you, sir.
I can hear you.
Please just be muted, please. Yeah. So to continue with the while loop.
Mr. Kenny, we can hear you, but it's just breaking.
Okay. So when the while, I'm trying to give a second example of the while loop. Okay. So like we have a program here. So write a program to sum numbers 1 to 10. Now, I just want to break this down. We need a way to sum. So at the first beginning, that's why I initialize our sum to be 0. The second line, counter equals to 1. What it's trying to do is like, you know, like I said, the first is that we must find a way to terminate our while loop because while loop by nature runs indefinitely. So when you put counter equals to 1, we just initialize. Now, the main condition that will terminate the while loop is the one after the while loop, like counter less than 10. So if we do not initialize it, it tell us counter is not defined. That's why we define it as counter equals to 1. Then we want this program to run as long as the counter is less than 10. The moment counter is equals to 10, it's going to terminate. So what do we want to do? Counter is 1, sum is 0. Remember, sum plus equals is the same thing as saying sum equals to sum plus counter. That's the same way, but in a shortened way, just put plus equals to counter. So that will be the right hand side. The left hand side, that's sum equals to sum plus counter. So sum originally was 0, counter originally was 1. So the right answer is going to do 0 plus 1, and that's 1. Then assign that answer to the sum, which is at the left hand side. So now sum is 1. Then we say, oh, print that sum, which is 1. And then when you, after printing, increment the counter from 1 now by 1, which will go to 2. So the first print sum is what you are seeing here, 1. Then counter goes to 2. It will come back, check, oh, counter is less than 10. Then it runs again. Remember, counter is now 2. Sum is 1. So it comes to the second line and do 1, that's sum, plus counter, which is 2, that's 3. It prints it, that's the 3 you are seeing here. Then it increase counter again to 3 and check. So the moment counter gets to 10, the program terminates. For instance, if we do for counter less than 5, that means the moment counter is less than 5, it's going to stop. And you can see it gives us 1, 3, 6, 10. So if you add numbers 1, 2, 3, 4, and 5, you're going to get what you have here. So the first one is 1, 1 plus 2 is 3, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So it's going to give us that. So it's going to stop the moment this condition that you put in front of the while statement is not correct. So that is about that. So the main thing, what I'm trying to say is that when you are using while statement, you must put a condition there that will help you terminate it. However, while statement can be confusing sometimes. So that's why for loop is very, very easy and convenient and more popular. So even me, I prefer for loop instead of the stress, because if you want to use while loop, you must initialize it, or else it will not work. Okay, look at this for loop, the same program. So we need a sum or total. Okay, we say, okay, let total, put it as initialized as 0. Then as far as my number is between 1 to 10, 1 to 9, for others, for I in range 1 to 10, what do? Increment my total for me. Total equals to total plus I. Remember, total is 0. So the first line is going to do I, the first iteration of I is going to be 1. So it's going to do 0 plus 1, and that's 1. Then you print it. So if you do that, even if we do 5, you will see that we are getting the same thing as that while loop. So instead of going through the stress of this while loop, why can't you just do for loop? Or at least it's better for you to have an idea of both. But for loop is what you'll be using most often. Any question on the for loop and the while loop? Any question? Are we good?
Yes.
Awesome. So let's move to while, because while true. While true is if you don't know the condition, you don't have a particular condition, so you want this to work, you still want to use the while loop, but you don't know the condition to put there. So look at this, write a program to some numbers collected from a user, because we don't know the condition here. We just want to collect number from a user. And then we want the program to quit as soon as the user inputs 0. So the first thing, initialize it, sum equals to 0. Now, while true, anything is true actually to programming. So that's why you use while true. While true, meaning as long as as long as the user keep on entering something, keep running this. But because we want the program to quit when 0 is account, that's where the if statement comes in. If the user inputs 0, that's break, because we want the program to stop as soon as the user puts 0. That's where we use the word break. Please try and be muted so that it doesn't distract others too. So the first thing, when we say while true, we collected something from the user. We say, okay, input, enter a number or 0 to quit. Because it's a number, we convert it to an integer and we save it in the variable imp. Now, if that imp is equal to 0, break. But if not, jump to sum the number plus the 0 that we already initialized as sum. And then at the end of everything, print, give us back the sum. So that's exactly what I'm doing here. So if we run this, it will tell the number, the user, enter a number. Suppose I put 9. It will keep on working, keep on asking me since I do not put 0 there. So enter a number. I put 7 now. Another one, I put 10. But if I put 0 now, you can see it quits. And then add the 9 plus 7 plus 10. So sum is now 26. So that's how to. So if you want to stop your Python program, your for loop, as soon as a user enters something, then you use break. All these things are used. Like in the ATM machine, I'm saying that if the user enters, keep trying this thing 3 times. Break and print out something. Break, just stop. You know, it will flag something. So all these things are used in what we interact with, in the product we interact with on a daily basis. So that's that's the help of break statement. We can also have what we call continue. But before we do continue, actually this is the same thing using another way, not using true, but I will leave that for you to go through that yourself. But let's look at another way of using break before we look at maybe continue statement or nested loop, where we can have loops nested within an already loop. Let's look at another applications of break. Now write a program to use the element of the second list to check that of the first list. So when we do that, okay, then the program should stop once the element of the second list is in the first list. You have 2 lists. You now want to check if the element of the second list is in the first list. If it is, it should stop. And that's simple. So you already have the 2 lists. The first list has ice, 3, 5, cream, soap, 10, 23. The second list, we have baby, 10, 13, sugar, soap, something like that. Now, so we need, since we want to check the first list, we need a way to look through the list. As I say, okay, for I in first. So remember, I is just a counter. It doesn't mean anything. So the first time I will go, it will pick ice. The second time it will pick 3. The third time it will pick 5, like that. Now, I will pick ice the first time. Now, since we want to check it with the second list, we have to now say, okay, if remember we used the in operator in the previous class. If this remember the first I is ice. If ice is in the second list, break. But if it is not there, it will keep going. It will go to the second one. And then we want to print out the exact I. So let me so the first time we run this, it tells us the I that is in the first and also in the second one is soap. And we can see. If I put on 10, the reason it didn't give us 10 is because in the first list, soap comes before 10. If I put, if I put 10 before the soap, let's see. Let's put 10 here. So let's see what it's going to bring. You see, it prints 10. Because remember, we are checking the first, we are actually going through the first list. And then we're using it to check the second list. So that's why it's going to go by the order of the first list. So that is how it works. So that's just an example of break. It's actually easy. Just put it, if you want to stop your program, put the condition. If this condition is true, then break. Then it will break it. So that's one way to break your program. Let's look at what we call nested loop. Nested loop is just like you have more than one loop. You guys have been using it. I saw it in one of the exercises you guys are working with last class. but to make it so that everybody will be on the same page, nested loops, like you want to put another loop in an already existing loop. So let's say you have already a loop called list 1, where we have London, Paris, New York, Berlin, and so on. Now, what we want to do is we want to loop through the first list, assign it to something, to another variable, and then we loop through that list again that variable that we've already assigned the list into, and then check if a particular letter is there. Once it locates that letter, it's going to break, and then the program is going to stop. Once it locates that letter, it's going to break. But I just want to, this is a naive example anyway. So like the first line for I in list 1, I, remember, is going to go through each of that list. The first I will be London. Then we assign that London to string 1. Then now we want to now loop through London. So if you are looping through London, for instance, let's see, just to give you an example of what it is. Let's say you have a string called string 2, called London. Then if you loop through these, that for I in string 2, what do? Print I. It's going to give us the letter. You see, it gives us each letter of that London. So that's exactly what you are seeing here. So when you do for I in list 1, the first thing I represents is London. It assigned that London to string 1. Then now you want to loop through each element of that London. So that's what you say for A in London in string 1. So now A will now represent each letter of that London. If A is equals to O, letter O, break. Meaning, once you see that O, pause there and then print A. So it is going to continue, but it's going to stop at, it's going to skip this A. Let's see. You see, it skip. So when it pick London, as soon as it saw O, it's going to stop there and move to the next word. So it stops there, it only gives us L. It moves to the next word, Paris. Assign Paris to string 1. It loops through Paris, and because it didn't find A, it gives us the whole word, Paris. The same thing with new. But when it gets to York, you see, it prints Y, but as soon as it see O, because York is one combined string, it actually leaves that, and it just gives us Y. It goes to Berlin and so on. So that's how, I'm just trying to give an example of how a loop you can actually fix more than one loop together. So that's what we call nested loop. Okay, any question on there before we look at the continue and pass? All of these ones, don't worry, we're just trying to get you used to what some of these functions. By the time we start working with data, we'll see how we're going to be writing a program that will combine most of all of these things we are doing. But I don't just want to jump there so that by the time we are working with it, you're not like, oh, what is this? You'll not be memorizing. No. But once you have at least a basic understanding of each of these functions, each of these programs, by the time we write a program that will put them all together, it will be clear. So any question on that before we look at the continue on the break? Any question on that? Are we good? Hello?
Yes, we are good.
All right. Okay, so the continue statement is just like opposite of the break. Instead of breaking, we want it to just skip that and continue the other one instead of breaking the whole word. So just skip. That's the word continue. Like look at this variable movies. It has list of strings there. We have PS, I love you, Shutter Island, less, that's the French word, miserable plane. These are list of movies. Now, if we want to look through the movies, and once we see the movie Less Miserable Play, it should skip that movie and give us the rest. That's what continue will do. Now, instead of break, don't break. Just skip it and continue. That's what continue means. That, okay, for I in movie, that one we are trying to look through it. If I, remember the first I will be PS, I love you. If I is equals to less miserable play, continue. But I is not even equals to, so it's going to give you. But as soon as you get to less miserable play, it's going to skip that word and go to the next word. Yeah, so it's going to skip the whole word. That's exactly what this is. So if we change it now, let's change the name of the movie. Let's change it to Kings. So I want to quickly say that when you are using, when you have like this apostrophe, it's better use double quotes. So King's Speech. You can use, I use double quote because I have a quote, a single quote, because the way Python works, if you use a single quote, it will assume that your code starts from that Kings is one word like that. So it might stop there, it might give you error. So so what this will do now, this will skip the word King's Speech. So see, it gave us every other one except the King's Speech. So that's continue. If you want to skip a particular word and you want your program to keep working instead of just pausing, instead of stopping, so you use the word continue. I'm trying to move fast so that we can get to functions and then we'll stop there. And maybe during the week, this one, I mean, we might do some little teaching, but it's still more of Q&A session. But from next week, Saturday, we should be done with core Python and then move to data from next week Sunday by God's grace. So the word pass is nothing. Is nothing but just a way of making your program run. If you want to write a function, you don't know what to do. Like you don't really know the content of that function at the very beginning. So what you do, once you write that function, just put pass, or else it will give you 0. I will talk more on this function next, but just look at the word def. Def is a keyword which is a short form of define. When you want to define a function, I will talk more on this because the next thing is function. You start with the keyword def, meaning just define a function. The func is just a function name. It can be anything. That's the name I'm giving to it. Suppose you don't know the content and you just stop. Remember, your function, you have to end it with a colon. If you do this, it's going to give you error. Because by default, there must be content under your function definition. So that's why if you don't know it, just pass it, meaning pass the function. When I know the content, I'll put it there. Just pass it for now. It will work when you just put pass. So that's the essence of pass. So let's just talk more about function. I put here something, little thing about functions that when you want to, what your functions mean, the categories of function, because you have actually been using functions. Some of them, we call it method. You know, some like the mean function, the max, even the sum, those are functions. But those are under the category we call the built-in function. So we're going to look at the two. Anyway, I won't spend more time on the built-in function because you have been using it, but I'll spend some time on user-defined function, the function you define yourself. Okay, built-in functions are all those count, index, find, min, max, sum, and some of those things. Range, those are built-in functions. But for user-defined function, first of all, you have to start with the keyword def, meaning define this function. And then you followed by your function name, then you end it with a parenthesis and put colon in front of it. Then I said that any argument to the function must be placed within the parenthesis that you have in front of your function name. You must end it with a colon, and the code within the function must be indented. You don't have to, once you put colon and press enter, it will indent it by default. Okay? So look at this one. I want to write a function to print hello world. So you start with def, def, then put your function name. I put hello world. Remember, I said you have to follow it by a parenthesis and then end it with a colon. Then what the body, so that's what we call, this first line is what we call the function header. Then the next line is the body. What do I want there? Just a short program. Print hello world. So that's it. So if I run that, then you have to call back your function. If you define a function, to make that function work, you have to call it by its name, hello. So I can also put welcome hello, anything you put inside the body. As far as you call the function, it's going to print. So it's going to, let me use Mr. Timothy. So he said welcome home. So welcome home, things like that. So anything you put inside the body, but make sure you call back your function. Make sure you call it back. So, but this is just a simple example of a function without any argument. So let's look at a function with argument. Now, I want to say this, that a function is not something different from a normal Python program you have been writing. It's just that you don't want to keep writing that program all the time. So anytime you know that you are going to do the same task, like repetitively, you're going to repeat the same code of block multiple times. So just write that Python program and put it inside a function, so that instead of writing the program every time, the Python code every time, you just be calling the function. That's all. That's why we use function actually. So it's not a separate program. It's just a way of shortening your code, that instead of writing the whole Python code every time, once I call the function, it's just going to run the program I've written once. I can only go back to the function and change one or two things. That's all. So it's just a way of shortening your Python code. So we want to write a function to sum two numbers. So I define a function called add and put two arguments, the a and b. Though a and b can be any numbers. What do I want to do to argument a and b? I want to sum a and b, a plus b, and save it in a variable c. If you put the word return, so to get a result, you have to put the word return. The reason the first function worked without using the word return is because we put print. Print means to display to the screen. But if we do not put print, it will work, it will run, but you will not see any result. So we said, oh, return the addition of that. So if you do that, it's going to add this. We can even multiply them. Let's say we do the function products. Okay, so what do we want to do? We want to multiply the result of A and B, and then we return C. So let's just change the function name, products. And then if you run this, you see, it multiplies A and B, 10 times 50, 500, and save it in a variable called C, and then return the result for us. Okay? So any question before we move further with function? Any question on that? Are we good?
Yes, sir.
All right. So now there are some functions that you don't want to, you have a default argument, like you don't want to keep entering that argument. That argument is default. You already know the value of that argument. We call that default argument. So, and that's the one you specify. For instance, look at the function. You want to define a function. You want to get information from a user. So, but you already know the age of the user. Maybe the user's age is 50. You already know that one. That one is constant. So you specify that inside the function as the argument. So that's default. So you won't need to impute that every time you call the function. It's already a default argument with something you know already. So, but the one you'll be entering now will be the name. Okay, but we know the age. So print name is this, age is this. So you can, however, even though it's default, you can still change it. Anytime you want to change it, you have to specify it. But if you don't want to change it, it will keep giving you what you've already defined the function to be. So suppose I put this and let me comment out the second one. So if you run it, it's going to give you the name that I put there, Kenny. I put age, put 50 there. So because it's printing out 50 because that's the default. But if you want to overwrite that, suppose I put this now, and I put 45. It's going to give me the same thing that the reason this is giving me two things is because I'm calling the word print two times. So that's why it's just, so name is Kenny, age is 50, that's the first one. Name is Kenny, age is 45. So that's the second one. Because the reason this is giving us because we put print inside, print two times inside the function. So anytime you call, and I'm calling the function twice, so it's going to give me that. That's why it's giving me this result. So let me, maybe I should just comment this on how. Then you can see. So when I call it the function, I give me the name Kenny and put the age 45. But if I do not put the age there, this 45 is just going to give me the default, which is 50. So that would default argument. Another function that is not so common but is very, very important is this function with variable length. Like you don't know how many arguments you need, but you know you need more than one. Then we call it variable length. And that's why you see this asterisk here. So that's what this asterisk is doing. Okay. So asterisk here means more than, like multiple length, like multiple something, multiple argument that you want to accept inside that function. You see this play out very well when we start dealing with machine learning. So I have one constant variable called variable 1, but I know there is another variable I want to get that has variable length, and that is var high. I know it's going to have more than one. So, but the first thing I want it to print the first variable that we put there, and then since the second variable has more than one variable, since I want to get more than one variable, that's why I know that I can loop through it. If it's a single variable, you can't loop through it. But I know the second variable, that's why I put asterisk there. When Python sees that asterisk, it knows that you are going to put in, you can put a list, you can put more than one number. So that's why we want to loop. Okay, for variable in the second variable that has more than one, print other variables are. But look at it, when I want to print, I didn't put the asterisk. The asterisk just means variable. The real variable there is variable I. That's the real variable. The asterisk is just to tell Python that it can accept more than one value. So, but you can choose not to put but more than one value. Look at it. When I just put in 1, it's going to ignore the second argument because it's optional. That's why you put asterisk there. If you run that, it does give us the result 60. But if I want Python not to ignore that second one, and I call the variable, see, I put 100. The 100 will stand for the first variable. The second, this 120, 135, 200, we stand at the second variable because it's variable length, like variable argument with more than variables. It tells us that, okay, the first one is 100. Other variables are 120, 135, and 200. Okay, and this is printing down these 3 times because I loop through it and I say, oh, for I in this, give me those variables. That's why it's giving me 3 times. If I don't want to give me 3 times, it won't. Yeah, so, okay. So that's just about variable. You might not really know the importance now until when you are writing a long, machine learning code or even deep learning stuff. That's just to make Python that you want that function to accept more than the input you have there, but you don't know the arguments you don't know it ahead, you don't know it in advance, but you know that you are going to actually put more than one variable there. So that's the essence of using that. Any question before we look at this lambda? Lambda function is key. And you see that you start using that one from next class, next Sunday, like when we start dealing with data. Any question on the function?
Answer.
So are we good? Okay.
No, sir.
Yeah. Go ahead.
Hello? Hello?
Go ahead, please.
Hello? Yeah, I want to ask a question. These AGR and asterisk VAR.
Yes.
Is it the same thing as AGR and quarks or something like that?
ARG max, is that what you're saying?
No. I think while I was doing a personal study,
Okay.
I see something like asterisk quarks. They talked about arcs and quarks.
Oh, yeah. So they are in the same like
Okay.
quarks is just syntax. Those are syntax. It doesn't mean you put quarks there. But quarks there means it's the same thing like multiple arguments. So you see asterisk, you can put one asterisk, you can put two. When you tell Python, once Python see the asterisk beside the arguments you are putting there, it tells Python that these are optional arguments, but I can let it allow even the argument I did not define. For instance, if you do not have this asterisk there, it will tell us that, it can tell us that variable is not defined. But if we put asterisk or asterisk before it, then Python allow that, oh, you do not define it, but you've already given me an instruction to accept anything you put there. Do you get it? So it's a way of letting Python accept variables that we did not define. Does it make sense, sir?
Yes.
All right. So I want to talk on
Sir.
this and not. Hello? Okay. I want to
Yes,
talk
sir.
on.
Yeah.
Go ahead.
Is there a difference between asterisk arguments and the asterisk keyword arguments?
That's what I'm saying. These are, both of them are saying the same thing. It's a way of allowing multiple arguments,
Okay.
things you do not define. Yeah. Okay?
Yes.
All right. So this lambda function is actually a function you'll be using most of. In fact, for the assignment one, it's a pity that only one person did it. I think I replied, Okpe was the only one that did it, as far as I'm concerned. As far as I know, I told him there is a question that I said, oh, you could use lambda function. Because lambda function makes life easy. It's called anonymous function. One, just know the rule. We can, in fact, we'll be using this on a lot of data and all of that. You may want to create a new column in a particular data that is already, you have in rows and columns. You can just use lambda function on it. You create the column and put in the values for you depending on the condition you specify. But you see how the naive way of using it. Most of these things. The idea of this Python foundation that we're doing is just to introduce us to it. Okay? It's not to go in detail. When we start working with data, we'll start working with them in detail. So now, one thing you need to know in your lambda is that it can take any number of arguments, but you can only have one expression. Let me say what that means. Now, argument is what you have in front of the lambda. It can take any. But what comes after the colon is what we call the expression. It can only take one expression. So like this now, I want to define, use the lambda function that we add 10 to any number that is passed in as an argument. So you have a lambda, you want to put in an argument. So since the only argument we want is just 10, we want to add 10 to something, that will be in the expression. But the argument is like, that will represent the input that the user actually, to get input from the user, that's like the input there. So let's call that maybe B, and then you put colon. Since I only just need one argument, okay? The expression it must be one. What do I want to do? The B represent what you want to get from the user. So add 10 to whatever the user is giving you. And then I saved it in a variable called X. This one is optional, but because I want to reuse it, that's why I save it as a variable. Then, when I put X15, 15 is representing the B, because I want it to add 10 to whatever I'm supplying it. I can even change it to 30. So that's what B represents. So if this is expected to add 10 to that B, which is 30, and that gives us 40. So the 30 is representing the B. So you will see this most often, instead of using B when you are dealing with a real data, we can use it with an apply function, and the B will be representing the column we want to do that for. You will see that play well when we start dealing with data. So that's a naive way of using lambda. You can also put in more than one argument. Like, I want to multiply, I said a lambda function that multiplies argument A with argument B. So that means I need two arguments, A, comma B, and I want to multiply them together and save it in a variable called Y. So when you supply these two, to multiply the two numbers together, if I put 20, it multiplies them together and it gives 100. So that's just a naive way of using Python, lambda. It's called an anonymous function. Like, you are not using the keyword def, but it's also a function. So you can put, like I told you, you can put any number of arguments, but there must only be one expression. Remember, the expression goes after the colon sign, after the colon operator. That's the expression. What comes before the colon is the argument, number of arguments. What goes after the colon is the expression you want to perform, the operation you want to perform on the input. And that is that about that. You can also use it with your user-defined function. Like, I define a function called myfunc. Remember, anytime you want to define a function, you use the keyword def. Myfunc is the function name. N is the argument I want to supply. Remember to end with a colon. What do I want to return? I want it to return the product of the argument, the input I want to take from the user, and the N I supplied with it. So that's what I want to do. So when you call myfunc, because we put N, you have to supply an argument. I put 5 in this case, and I save the variable as doubler. Now, the 10 I'm putting here is representing the argument A that is in front of lambda. The N is representing 5, but the A is representing this 10. So that's what, so I have to run that and then come here. Let's say I supply 20 instead of 10. Okay, if I do that, it returns the operation that I put in front of the column. Any question here before we look at the exercise?
Excuse me.
Yes,
What is the advantage of using this lambda with user-defined function over the ordinary lambda? Because like what you did on this example, this doubler example that you gave, we can actually do that using just a similar expression of lambda. So what is the advantage of using lambda with user-defined function?
there's no advantage actually. It depends on what you want to do. In most times, so I just gave you 2 scenarios, because when we start working with data, you will see a case, most cases we will be working with lambda directly, like applying lambda on the particular column or feature of that data. But I use it with the user-defined function in case you define a function for your program and you still want to use lambda inside that function that you define. So that's why I gave the 2 scenarios. So depending on what you are doing, if you are writing a function for your program, and you want to use lambda, you can. I'm just showing you that you can also use lambda inside that function. But we can use, but in most cases, we'll be using lambda directly on the variable we want to use. Does it make sense, sir?
Yeah, perfect.
All right, so we can go. I will pause record. I will stop recording so that we can go to the breakout rooms and do the other exercise.